if we want to graph 3 cos 2 theta, so now we have graphs that have more than one transformation. Okay, so it wasn't too difficult when we had only one transformation because we could probably apply it directly to the graph. If you have more than one, it is very useful to do the mapping notation. So first of all, I'm going to describe my transformations. So that will always be asked. It might ask you, what's the amplitude? What's the period? Is there a vertical shift? Is there a horizontal shift? So remember that transformations are in general. So the number at the beginning is a vertical stretch, which is the amplitude. So we can state the amplitude of the graph is 3. Any number that it's added at the end is a vertical shift. We don't have one, so we don't need that one. So this is a vertical stretch. This is a vertical shift. Okay. Inside the brackets, we might have a horizontal stretch, which will affect the period, and we might have a horizontal shift. Okay, so this one has a C value. So that is going to affect the period of the graph. So a normal period of a sine and cosine curve is 360. If we have a value of C, that is either going to stretch it or compress it in the inverse way. So the 2 will divide the 360 by 2. So the period will be 180. The 2 means that I'm going to get the graph in twice in the normal 360 degrees. So I'm going to write my mapping notation. So the 2 will affect the x in the opposite way, or the inverse way, and the 3 will affect the y. It is a vertical stretch. And then I'm going to write my points out for cosine, my critical points. And then we're going to apply these transformations to these points. So to each x, we're going to multiply by a half, and to each y, we're going to multiply by 3. So that remains at 0, and that becomes 3. Half of 90 is 45, and 3 times 0 is 0. A half of 180 is 90, and 3 times -1. A half of 270, and a half of 360. So these are my new points that I'm going to graph. And the nice thing about mapping notation is that I can see what I would like to graph before I make my grid. So I think I'll just go to 360. I'll get in 2 cycles. So I'll go to 360, -360, and I want to go up to 3 because that's my max, and down to -3 because that's my minimum. Okay, so 6. So this is 180, this is 90. 270, and the same on this side. And then we'll just plot the points. So this graph starts at 0, 3, at 45 degrees, which is halfway between 0 and 90. It goes down to 0. At 90, it's down to -3. At 135, back to 0. And then at 180, up to 3. So there is one cycle. And then I can just repeat. So middle, bottom, middle, back to the top. And then I could repeat going left, so it would be in the middle, the bottom, the middle, back to the top. And I'll do one more, middle, bottom, middle, back to the top. So there's a few cycles of my graph. So you will be asked to write the mapping notation. That is important. And then if you do get your points right, but your graph wrong, at least you can get partial value for that. Okay, this one has 3 transformations. It has this negative at the beginning, which is a reflection. So it's going to be reflected vertically. The amplitude is always positive, and it is 1 because it's a -1, but the -1 means that it's a reflection with an amplitude of 1. The amplitude can never be negative. Because think about amplitude. Amplitude is the vertical distance of the graph, or the vertical height of the graph, so cannot be negative. Right? You can't have a negative distance. So the negative is the reflection. So don't put -1 for the amplitude. Okay, the period is normally 360 for sine, but we're going to divide it by c. And in this case, c is a half. So 360 divided by a half is like multiplying by 2. So 720. And it has a vertical shift of 3. So it's going to go up 3. Okay, so we have 3 transformations here. So my mapping notation, the 1/2 will change the x and it will double it, right? It's always the inverse. And then the negative will be applied to the y, and we will add 3. So the reflection is taken care of in the mapping notation. And it's sine, so I'm going to list my points for sine. And then we're going to apply these mapping notations. So the x we're going to double, so 2 times 0, and the y will be -y plus 3. So double, and then -1 plus 3 is 2. Double, and then 3. Double, and then negative times a negative is a positive, so 1 plus 3 is 4. And then 720 and 3. Okay, so this time my graph has to go up to 720 instead of 360. So I'm going to put 720. And so each of these, this will be 360, this will be 180, and this will be 540. Okay, I have to go up to 4. So 1, 2, 3, 4. So that's my maximum. And I'll go minus 720 to the left. Okay, so those are good scales on my axes. So the first point I'm plotting is 0, 3. Then at 180, it's at 2. At 360, it's back to 3. At 540, it's up to 4. And at 720, it's back to 3. So here's my graph. And then I'll just continue that going left. So we'll go up to the top, back to the middle, down to the bottom, back to the middle. And then I can always look at my graph and make sure that it seems correct. So here's the middle. I'm going to draw that in here. So the middle is at 3. This is my vertical shift, right? The middle is where the vertical shift is. So that is correct. I expected it to be up 3. My amplitude is 1, right? So that is correct. It's from 3 to 4 or 3 to 2, so that is correct. The period is 720. I can see that. One cycle is 720, so that is correct. And it is cosine flipped over. So instead of starting here and going up, it's going down. So everything on the graph looks correct in terms of my transformations. Okay, we don't want pi. This is my 3u. So pi is the same as 30 degrees. So okay, so we'll put it in degrees. Do I have another one here? No. Okay, so this is the last one. Okay, so both of these transformations apply to the x because they're both in the brackets. So the amplitude is 1 because there's no number at the front, so it's a 1, right? So the amplitude can't be 0. It's always 1 unless it's stretched. The period is normally 360. We'll divide it by c. Well, in this case, c is 3. And so the period is 120 degrees. And then we have a horizontal shift. Right? So we have a horizontal stretch and we have a horizontal shift. So it's going right 30 degrees. Okay, the amplitude, we don't have a vertical stretch, so the amplitude's 1. We don't have a vertical shift, so we're just compressing it by 1/3 and then moving it to the right 30. So both transformations apply to the x. So the x is 1/3, right? The inverse of 3 is 1/3. And then we're going right 30, so plus 30. Y does not change. And it is cosine, so always make sure that you've got the proper sine or cosine. Okay, so we're dividing the x by 0, or by 3, and then adding 30. So 0 divided by 3 is 0, add 30. Y stays the same. 90 divided by 3 is 30, plus 30 is 60. Y stays the same. 180 divided by 3 is 60, plus 30 is 90. 270 divided by 3 is 90, plus 30 is 120. And then finally, 360 divided by 3 is 120, plus 30 is 150. So those are my new points. One cycle takes 150 or 120 degrees, so I'm just going to go to 360. Well, let's see, I want to go by 30. So because my points go by 30, I want my grid to go by 30. So I might go, let's say 30, 60, 90, 120, 150, 180. So that way I can get in 2 cycles. And I'll do the same here, 30, 60, 90. So every square is 30. 1, 2, 3, 1, 2, 3, and then this is minus 180. And then my amplitude, I'm just going up to the normal 1 down to -1. Okay, so 31, so 30 is 1 square to the right and then up 1. 60 is 2 squares, 0 and 9, oops, that's not right. 60, 2 squares is 30, my bad. 2 squares is 30, so 31 is 2 squares and then up 1. 60 is here, and then 90 is down here. And then 120 is here, and 150 is here. So there's 1 cycle. Okay, so every 2 squares is 30 degrees. So I could just continue it, and then I can just continue left. So 2 squares middle, 2 squares bottom, 2 squares, that should be here. 2 squares, so let's see, 2 squares, 2 squares. Got one of those in the wrong spot. Mine's a little bit off. Okay. So there we go. And that's my graph. Okay. So transformations when we have more than one. Transformations, ideally you want to use mapping notation. And so that you can apply all the transformations. So you will be asked, what is the amplitude? What is the period? Is there any phase shifts horizontally or vertically or any reflections? Write out the mapping notation and draw 2 cycles of the graph. Okay? So the next lesson will be on writing an equation given a graph. Then